Now let's use dynamic polymorphism to solve our problem. What I will do is change the object type into salesman. So let's go ahead. Now we'll change this to salesman. And I will also change this to salesman. See, it still works. Then I will go ahead and rewrite the show me how to sell method and say that it only takes salesman type, and once it takes the salesman type, it just calls the sell method on it. So I will just say this is salesman, and then I will say, here's the beautiful part, I don't need any of this. Take all this stuff out, and I just say sell. Boom. That's it. All right? Isn't this much cleaner? And guess what? This is fully satisfying our business requirement. So if they added another type such as online marketer, it would still work without us having to touch the code. Let's go ahead and do that actually. I will go to Explorer, say new file, online marketer.cs. All right. Now I will simply just go here, grab that. You already know the drill. Rename, copy that, and that. Hi, my name is the full name. I would recommend you to buy this online product. Okay. And no developing. Just keeping it simple once again. All right. And let's go ahead to the program. And I will say new online marketer. And we will say Steve Rogers. Okay. Check this out. Beautiful. See, we don't have to touch our method. We don't do anything with it. They can add 50 types. They can add 100 types. They can have billions of rows. We don't care. This method will never change. If they change something other with their business requirements, for example, if they want to see the sell method and they want to do something else, yeah, we can change this method, no problem. But we don't have to change it based on the number of rows or any different types that they add. And that is beautiful. Let me go ahead and run this code actually. So I will breakpoint it right here and say run. And once again, we have our list. That's cool. We're going through our list and check it out. 1, 2, 3, 4, and 5. So 2-car salesman and retail salesperson, insurance broker, online marketer. It does not care. It just says as long as you are of salesman type, so you are inheriting from salesman, if this parent class is pointing to any of these child classes, it will be able to take care of it and call its sell method. So the sell method will be directed from the child class that's being passed into this method, which takes in the parent class. So the parent class will be pointing to one of these child classes, whichever one happens to come into this method. In the first run, the parent class is pointing to this child class. The second run, the parent class is pointing to this child class. The third one, this one. Fourth one, it's pointing to this one. And fifth one, it's pointing to this one, right? You get the idea. And as it's pointing to these classes, it knows how to handle the sell method. So this is what we mean by method overriding. The method has the same signature, however the implementation is completely different. Now that we've seen how to perform dynamic polymorphism using abstract classes, let's see how it is done using interfaces. Let's say our requirement now is very similar, but instead in the database they have types which are self-developing, and the rest of the requirements are the same. So once again, we would have a list of self-developing classes, and imagine that it has been loaded with all of the items from the database. In other words, let's just imagine for simplicity's sake that we don't have to instantiate a class once a new row comes into the database, but it is being loaded into the list here automatically. just like I mentioned before. And then all we have to do is loop around and pass individual items into our method. So what we do, I'm going to stop this, and we're going to just have another list, very similar, but in this case we're using interfaces. So I'm going to say self-developing, and I'm going to say self-developing, and we can't include these guys in there because none of them satisfy the interface requirements, right? So these can't be here. But guess what? Retail salesperson is not underlined red. Why? Because it is of type self-developing. Now the other type that we had was web developer. See, web developer, and we can have that here, and we just give it something like C#. All right, and that's cool. And then we will have another method that's similar to this, and this one says show me how you self-develop, and it's going to take an interface of type self-developing, all right, and it's gonna say call the develop method on self-developing, so not self-develop. Okay, very similar. Now we actually have to also change the method name. I forgot to do that. So change the method name, and the item that we're gonna pass into, also it's not salesman, it was just a copy paste there, so we're gonna have to go through all self-developing, and that's the item. We're gonna pass that item into show me how you self-develop. So show me how you self-develop, and then it's gonna show us how it develops. Okay, so now we're gonna go through, we're gonna run, and as you can see, we already ran through all the salesmen. That's cool, but now it's time for us to run through self-developing. All right, so now it's gonna go through, and it's gonna say I developed myself by watching retail sales training videos, because we had retail salesperson first one in the list. And then we're gonna go through the second one. It's gonna say I developed myself by watching Udemy web development courses, because it was a web developer. All right, so once again, same idea. If we add more types and we hook them up with the self-developing interface, we can include it in this list, and we can also put it through this method. Another beautiful thing is that if you have a abstract class or you have an interface, you are able to create regulation and stability into your program, meaning that you can lock into what can go into this list. For example, right now we have retail salesperson and web developer. If this was an object, then guess what? We can still do this. However, the problem here is that anything else we put in here that is not from an interface self-developing could get into this list. So for example, if it's a new car salesman, I copy this and I put it right here, this can get into it just as simply. But if we put self-developing interface, what this does is it creates a regulation. It creates boundaries around what can get into this list and what cannot get into this list. And it just basically creates, as I mentioned, more stability into our program. Another quick thing to note is the fact that right here, I have an abstract class, and here I have an interface. See, an abstract class unifies related objects. So car salesman, retail salesperson, insurance broker, online marketer, these are all unified, but these are all related objects because they basically have common functionality. Here, the interface can unify unrelated group of objects. So retail salesperson, web developer, they don't really have much to do with each other, but they're unified through an interface. So that's another difference that I wanted to show you through this code, even though we talked about it already, but it's a good demonstration of the same idea. So that's all for this video. We already went over the dynamic polymorphism, and in the next section, we'll be talking about encapsulation.